Now that you have calculated these measures of disclosure risk, k-anonymity, sample and population frequency, and individual risk and global risk, it's important to understand how to correctly interpret the results. This helps you take informed action and reduce the risk of disclosure taking place. Let's take our results as an example and start with k-anonymity. There are hundreds of records that violate 2-anonymity. In other words, there are hundreds of respondents in our sample dataset that have a unique key. Next, let's look at the sample frequency. Because the sample frequency simply counts the number of records within the sample that share a key, the numbers will correspond with k-anonymity. The total number of records with a sample frequency of 1, records who do not share their key with another record, is equivalent to the number of records that violate 2-anonymity. Similarly, the total number of records with a sample frequency of either 1, the unique records, or 2, the records that share their key with only one other record, is equivalent to the number of records that violate 3-anonymity. However, because neither k-anonymity nor sample frequency take into account the sample weights, these measures alone do not tell the full story. Depending on the sample weights, the hundreds of unique records could represent thousands of people in the broader population. What looks like a unique set of characteristics in our sample may be quite prevalent in the population at large. If this is the case, that would lower the risk of re-identification of the individual respondent in our dataset. This is why population frequency and the individual disclosure risk measure are important. Both of these measures take into account the sample weights. In this table, we can see that if a record has a higher sample weight, it will have a higher population frequency and a lower individual disclosure risk. If you think about it, this makes a lot of sense. If there are more people in the broader population that share the individual's key, it will be harder to re-identify that individual in the data set. Let's look in more detail at the individual risk measure. This risk measure tells you, at the individual level, who has high or low probability of being re-identified. This can help you identify individuals with a particularly high risk of re-identification and take steps to reduce that risk. We also want to look at the global risk measure to have a holistic understanding of the probability that any individual in our dataset could be re-identified. One common way to calculate this is to take the average of all of the individual risk scores. If using this average, it's important to approach the result with caution. Behind an acceptable global risk probability, say 2%, you could still have individuals with a high risk of re-identification that are compensated for by many other low-risk records. Every organization conducting a disclosure risk assessment will need to set their own threshold for acceptable risk. If we take the Center for Humanitarian Data as an example, we've set our threshold for publicly sharing microdata on HDX at 3% global risk. This is, of course, just one of the measures that we use when assessing the overall risk of our data. We also look at the k-anonymity and assess the individual risk of re-identification to make sure that the risk of disclosure for a specific individual is not too high. These different measures allow us to decide whether and how to share microdata. In the next video, we'll look at different techniques for reducing the risk of disclosure and sharing data responsibly.